Alright, welcome back. In the last video we played around with these bearings. We came up with a diagram for our horizontal curve. It is by chord definition, and we use these parameters to figure out what delta and the radius of the curve is. Okay, so in this video, the next one, we're going to figure out what L is, or the length of this curve. So what's the distance between BC and EC along the curve? Okay, remember our formula for the length of the curve is 2 pi r delta over 360 degrees, right? So if we plug in what we have so far, we figured out what the radius is. The radius is 716.78 feet, and our interior angle is up here. It's the 61, 37, 48 interior angle, and 2 pi r delta divided by 360 degrees. Okay, so if we work our calculator magic, we get L is equal to 771.00 feet. So that's the length of our curve. That's the length from BC to EC along this red curve. Okay, so we figured out what L is. Cool. Now, our next variable we need to figure out is, what is the long chord? And remember, the long chord is a straight distance from BC to the EC. Oh, that actually crosses to the BC. So what's this distance, right? And our formula for long curve, right? It's the same formula we used for our degree of curvature. Our LC is equal to 2r sine delta over 2, and we have r and delta. That's our radius and our interior angle. We can plug that in. 2 times r is 716.78, and sine of our interior angle, which is 61, 37, 48, and that's divided by 2, right? Plug that into our calculators. We should get LC is equal to 734.37 feet. Okay? Cool. We figured out something else. We figured out what the long curve, or the long chord is, right? Let me just make sure this is right. Yeah, it should be right. Now we need to figure out two more things, and that's our tangent distance and our pi, right? So we need to figure out what this is and what this is. Our tangent is our distance from BC to the pi. Let me label this pi. And our pi is the station where the two tangent lines intersect. Okay? So we need to figure out t first, right? So t we have a formula for. It's t is equal to r tan of delta over 2, right? We know what our radius is. Our radius is 716.78 times the tangent of our interior angle divided by 2. 48 seconds divided by 2. We plug that in, and we should get 427.54 feet. Okay, so our tangent distance, our distance from BC or EC to the PI, is 427.54 feet. Right? We figured out what T is. Now, to find our point of intersection, remember, we are given the EC, the station, 25 plus 0, 0. That's our ending of curve, right? Our EC. We can't subtract this distance t to just get pi. What we need to do first is subtract L to find BC. Then to BC we add t to get our pi. Okay? So let's do that. First thing we need to do is subtract L from EC. So EC minus L will give us our beginning of curve, right? Our EC is 2500, remember that's given in the problem, minus the length, our length up here is 771.00 feet. And if we do the math, our beginning of curve is equal to 1729, okay? Or, it should be an arrow, 17 plus 29. Okay, so that's the station of our BC. Okay, so to the BC we're going to add the tangent distance, and that's going to give us the station of our point of intersection. Our beginning of curve was 1729. Our tangent we figured out here was 427.54 feet. We add those two numbers together, we should get 21 plus 56.54. Okay, that right there is the point of intersection. Cool. So we figured out all these parameters using what we know about horizontal curves and this bearing business. Okay.